This is Unit 7 on percent, and on Day 2 our learning target is I can write and solve percent problems. Today we're going to review a little bit about what we discussed yesterday, and we're going to add an extra method to solving percent problems. Yesterday we talked about the proportion method, and today we're going to talk about the equation method. Okay, just as review, and you might want to jot this down in your notes, percent means per cent or per penny, and there are 100 pennies in a dollar. So when we see percent, it really means per 100. Make sure you have that jotted down in your notes. And then we're going to move on. Here's an example. We're going to convert between percents, fractions, and decimals. Here we have 50%. Here's our percent sign. And we have our visual of 50 squares shaded out of 100 total. So this is 50% of the squares shaded. We can also write that as 50 hundredths because 50 of the 100 are shaded. If we say 50 hundredths, it's just like saying 50 hundredths. So that's how we get our decimal. If 100 is in the denominator, we can say it 50 hundredths and write it as a decimal. Now it's important to remember that fractions need to be reduced to simplest form. So 50 hundredths I know can be divided by 50 both in the numerator and the denominator, so I get a reduced fraction of 1/2. So 50% equals 1/2, which equals 50 hundredths. If I want to go from the decimal to the percent, I'm going to need to multiply by 100. So 50 hundredths times 100 would be 50%. And we go back to our 50%. So let's have you try some of these. Make sure you've taken good notes, and here we go. So for the first one, you're given 20%, and you're asked to write the percent as a fraction in simplest form and as a decimal. For number 2, you're asked to write the decimal 75 hundredths as a percent and as a fraction in simplest form. So go ahead and try that. And last, you're given the fraction 1/4, and you're asked to write that as a percent and as a decimal. So the vocabulary terms we're going to talk about today are discount and markup. It's important that you write down these equations. Discount refers to the price. If you have an original price and you subtract a discount, that refers to your sale price. So once again, if you buy something on sale, they found that price by taking the original price and subtracting the discount. For markup, we're talking about adding a wholesale price and the markup to get the retail price. The retail price is what you would pay for an object, for example, at Macy's. So it's your original price, whatever it's going to sell as. So they buy the t-shirt, for example, at a discount because they buy a huge quantity of them. And then they add some dollars as a markup so that when they sell it, they can make some money. Remember, they're going to have to pay for the store and they're going to have to pay their employees, so they need to add something to the wholesale price so that they can make some money. Okay, we're going to try our first problem using proportion, and we're going to calculate sales price. So you are shopping for a guitar and find one with an original price of $160. The store is offering a 30% discount on all guitars. What is the sale price of the guitar? Well, since we're going to use proportions for this one, I'm going to write down my percent proportion, and then I'm going to substitute in. The original price is $160, so that would be our base price, and it says that it's offered on discount for 30%. Now, the question asks what the sale price is. If we get a discount of 30%, we're actually paying 70%. So let's substitute 70% in for P. When we do that, now we can solve to find out what our sale price would be. So when I solve, I'm going to do it with the multi-step problem. So I'm going to get rid of this denominator, so I'm going to multiply both sides by 160, and I'm going to find out that the part, or the sale price, is going to be the discount times the base price. So that's going to be the same as 70 hundredths times 160 over 1. Now remember, I can cross out now, so it's easier to multiply. I know 20 can go into 100 and into 160. And I know I also can reduce 70 and 5 because 5 goes into both of those. So now I have 112 over 1, or $112. So the sale price is $112 for the guitar. Now we're going to talk about the percent equation. So here's the problem that we just did on the previous slide. Here is our proportion, and we substituted in and we solved for A. The equation says that the part is equal to the percent times the base. You can see that right here. The percent equation is a shortcut. So what it's saying is the part of the price is going to be equal to the percent times the base. So let's write our percent equation down and substitute in what we know. We know 70% is the price we're going to pay for the item that costs $160 originally. When we convert our 70 hundredths to a decimal, we will get 0.7 times 160. So our part, or our partial price, is $112. Again, we're going to pay $112 for the guitar that's on sale. Okay, so let's try another problem. It says a shirt has a wholesale price of $16. The percent markup is 120%. What is the retail price? So I'm going to use the proportion. So that's where I'm going to start. I know retail price equals the wholesale price plus the markup. I know the wholesale price, but I need to find the markup first, and then I can find the retail price. So my first step is to find the amount of the markup. I know that it's 120% for the markup, and that the wholesale price is $16. So if I solve for A here, I find out that A is $19.20. Remember, we're talking money, so that 19 2/10 is really $19.20. Now I'm going to add that to my wholesale price of $16 to find out that when I walk out of the store, I'm going to pay $35.20 for that wholesale shirt. I'm sorry, for that original price of the shirt, the retail price. Now we're going to use the percent equation in this problem. It says a portable CD player costs $48 before tax. The sales tax is 4.5%. What is the total cost? Well, we need to find out what the sales tax is and add that to the price of the CD player to know that what we're going to pay when we walk out of the store. So here's our equation. We're going to take 4.5% of $48. Remember, of means times. So that is 45 thousandths times $48 for our base price to know that we're going to pay a sales tax of $2.16. So next, we're going to add the sales tax and the item of $48. So we have $2.16 plus $48, so that when we walk out of the store with the portable CD player, we've paid $50.16. Here are a couple of problems for you to try. You can use either the proportion method or the equation. Number 4 says a shirt has a wholesale price of $64. The percent markup is 85%. What is the retail price? And number 5 says a CD costs $8.90 before tax. The sales tax is 5%. What is the total cost rounded to the nearest cent? And before you finish, tell me something that you learned or were reminded of, and a question that you have.